right. Welcome, everybody. Welcome to VMed 24. Who's excited to be here? All right, I like that. You're not even making me say, who's excited to be here? You did it the first time. That was great. Well, thank you all for being here. It's amazing to see all of you. This is our Super Bowl. Every year, our team works throughout the whole year to put on this conference. And it's for this moment, for all of you guys from truly around the world to converge here in this room to talk about this field that we all love, this new emerging field that we call MXR, Medical Extended Reality. You guys come from 17 different countries this year. We have over 400, let's clap for that, absolutely. 17 countries. Over 400 registrants this year. It's amazing to see the breadth and depth every year of the people that come to this conference. It's such an interdisciplinary conference. Of course, there's people from healthcare, there's people from outside of healthcare, from entertainment, from computer science, from industry. We have physicians, we have nurses, we have it's just so many different types of people in this room that all converge to learn from one another. And so our hope is, of course, that you learn as much from each other as you learn from those of us on the stage that will be, giving talks and giving lectures. So excited you guys are here. And my goal for the first part today is to set the stage. And in doing so, because we have a lot of people that are new to this field, I want to give a little bit of a history of where did this all come from. There's so many people upon whose shoulders we're standing. Many of them are here in this room right now and will be speaking in this conference. And this is an opportunity to learn how did we get here and where are we going. So that's really my focus on this opening talk. And to frame this, I was born and raised in Los Angeles. This is my home. And 100 years ago, if you were to look out just down the street, this is what it would look like. This is 100 years ago. This is taken around 1919, Los Angeles. And it's incredible to think about the difference between just 100 years ago and right now, because I just took this photograph as I was driving around the neighborhood a few weeks ago, and we're now seeing these in the streets. Something that might look archaic in 10 years, right? You remember the DeLorean and how, classic that is. I don't know what we'll think of this thing in 10 or 20 years, but life is moving fast, and no one in this photograph would have imagined seeing an automobile like that on the street, much less one that drives itself, right? These are incredible exponential advances in just 100 years. And so that's really the first concept that I want to get across, is that we have this incredible exponential growth, and we have to keep up with that in a room like this. So let's take a look at this famous picture from the futurist Ray Kurzweil, who made this picture along with many others in his book in 2005, The Singularity is Near. And it's really hard to even wrap your brain around what we're looking at here. Okay, this is a linear plot looking at the beginning of time. Okay, this thing called the Big Bang happened, such as we understand it. And the universe expanded and became whatever it is that we see here. At least we think there was a Big Bang. I guess there's some questions about that now even. And all this inorganic material somehow turned into life about 4 billion years ago. Who knows exactly how that happened? Was it at a hydrothermal vent? I don't know. But then not a whole lot happened until about 1.5 billion years ago, when all of a sudden we have eukaryotic cells. And then reptiles show up, and then look at what happens. You turn the corner, and next thing you know, you have Homo erectus. And then in the blink of an eye, in like basically one sentence in a book, all of a sudden we have the Apple Vision Pro. How did that happen? Right? How did we go from standing up to having a computer with 23 million pixels, where we've taken the inorganic materials from which we were born somehow and rearranged them to create computers that can both delight us and store the burgeoning knowledge that we can no longer store in our own minds? That's something we need to get our heads around. And that's something we need to talk about today, is this exponential growth that, of course, was enabled famously by Moore's Law And we have Daniel Kraft here, who is very frequently speaking about Moore's Law. In fact, I think I first heard about Moore's Law from Daniel. This is back all the way in 1965 when Gordon Moore, the co-founder of Intel, famously predicted that the number of transistors on a chip will double approximately every 2 years. And what we're looking at here is a logarithmic plot, not a linear plot, but a logarithmic plot demonstrating the exponential ability to perform calculations per second per $1,000. So not only are we getting faster and faster, but it's getting cheaper and cheaper and more efficient. And eventually physics will put some ceiling on this, but we haven't hit it yet. So what we're then seeing as a result is an exponential rise, of course, in our technology and our technological capabilities. And if you look at the top here, there was the agricultural revolution. 8,000 years goes by between that and the Industrial Revolution. But then as you start moving along, from the moon landing to the web was 22 years. From the web to the human genome was 9 years. We had to see this exponential drop in the ability to do incredible things with technology. And then we see this exponential growth in computing power. And eventually, the prediction is this will lead to this moment in time that Ray Kurzweil calls the singularity. And the singularity is this moment that he described in his book, The Singularity is Near. And his new book, The Singularity is Nearer, is about to come out. I guess we're getting closer, so he has to write a new book about it. But this is really an incredible book. And he talked about how human intellectual power has been pretty stable. I mean, Rembrandt was just as smart as anybody on the planet right now. It's not like our brains have been getting that much smarter, but of course the computers that we created are storing and analyzing and integrating that knowledge. And what he predicts is this moment, which he thought would occur around 2045, when computers would surpass the ability of humans to be intelligent, whatever that means. And we can talk at length about that, and we will talk about what is the role for humans right now. And I'm going to come back to that later, because we need to store that question in the back of our mind as we think about a conference like this. What is the role of the human clinician, for example, in the world of artificial intelligence, in the world of spatial computing? We're going to get there to this sort of world of transhumanism that he predicted would occur. So Bill Gates is famous for saying most people overestimate what they can do in 1 year and underestimate what they can do in 10 years. I think we need to restate this. It's more like underestimate what we can do in maybe 6 months. A year from now, we might look back on this very conference and think, oh, that was really cute, or that was a neat technology, but now we can do X. And whatever X is something we could hardly imagine right now. There's just a handful of people in the world that can imagine it and will reveal it to us in 12 months or so. So I think about just when ChatGPT came out, which was, of course, an extraordinary moment, really in human history, I think. But of course, like many of us, I was sort of skeptical. And this is a set of tweets that I wrote when GPT 3.5 came out. And on the left, which you can see is dated December 11th, 2022, I decided to pose a series of board-style questions to the computer based upon some books that I had written in my field of gastroenterology, and the computer did horribly, did miserably. It had dangerous answers. There's no way it would pass an exam. I wouldn't want that computer near any diagnostic decision-making at all. It got about 35% right, and its answers were horrible. And then I decided to shame it by asking it to draw a picture of itself struggling to take the exam that I gave it. And this is the picture that it drew of itself with a mask covering its face, looking down, ashamed as it was failing this exam. All right, well, the punchline, of course, is GPT-4 comes out, and about 6 months later, I posed the exact same questions, 100% correct. Not only 100% correct, but with answers that were better than, honestly, any answer that I've ever heard from any of my students. And that's because it has access to the world's knowledge, and my students don't, as great as they are. So that's incredible. So we can't really make fun of these things anymore. We can maybe pretend to make fun of them, but we have to come to terms with the fact that technology is here. Now, moving to our field, this is a picture that I like to show a lot because of the emotional expression of this patient who's allowed us to show his image, as have the others I'll show today. And I've shown this picture many times, but this time I want to point out how old that technology is. I mean, he's having an incredible reaction to it, but that's a Galaxy S7 phone snapped into a Samsung Gear VR headset. These things don't even exist anymore. We don't use these things anymore. But at the time, this was an incredible thing. This was around 2016 that we were doing this. Now we fast forward to today, and we're doing this. You're going to hear more about this. This is using the Apple Vision Pro. This is a 23 million pixelated experience where a person can talk to a robot that is using 6 different forms of artificial intelligence to provide mental health support using natural language. And not only that, she's creating, if she's a she, I don't know, she's creating these environments that are countervailing the emotional experience of the user. And so we wrote a paper about this recently that I couldn't have imagined writing a year ago because I wouldn't have even known what these words mean, right? I mean, I kind of know, but like these are brand new concepts. You know, I don't know a year or two from now if we'll look at this video and think, oh, that was cute. I remember that. That was sort of funny. I don't know. But it's just so hard to keep up with these changes. And it's so exciting at the same time. So this is exponential growth. Now, if we look at the way humans approach change, we are evolutionarily built to think linearly. This is something that Ray Kurzweil always makes a big point of describing. We think that tomorrow will be pretty much like today, maybe a little different, and the day after a little bit different still, and it's going to be a linear progress, and everything's very predictable. But then we look around the world and we think, oh my God, how did that happen? We ended up here. And this is what's called the exponential growth surprise factor. So we need to be aware of this, even if evolutionarily we're not prepared to think that way, and then we're always shocked and then sort of almost dismiss the fact that it can't really be like that because it shouldn't be like that, but it is like that. So we have to, as Wayne Gretzky famously say, kind of skate to where the puck is going, and I'll come back to that in a second. This exponential growth is reflected in the biomedical literature. This is a PubMed search of papers that focus on the use, in this case, of just virtual reality. I'm not even using the terms augmented reality or spatial computing or extended reality. You can see this exponential rise in just the papers that are being published, enabled by this technology, by many of you in this room. And this is now over 25,000 papers in the biomedical literature for this field. This is not a fringe science anymore. It's a real science. There are tens of thousands of papers that are being published. And so I mentioned Wayne Gretzky because when he was asked famously, how are you so good, the best hockey player ever, he said, oh, it's easy. I just skate to where the puck is going. I don't skate to where the puck is or where the puck has been. I predict where the puck is going to go, and I skate to that part of the ice rink. Well, that is really smart, and we need to be thinking the same way, except the puck is moving faster and faster as it moves. It's not moving at the same rate. It's exponentially moving. So it means we have to look out even farther if we're going to intercept that puck. And I don't mean like futurists thinking 10 years into the future or 50 years into the future. How about just 6 months into the future? Okay, it makes it very challenging to do this work. So with that background, I now want to trace how we got to where we are today in this room and talk about many of the people who are in this room who made that possible to get us in a room like this today, focusing now on medical extended reality and its progress. And really, this is a story that goes back to the mid-century, mid-20th century anyway, with this foundational era with incredible advances in technology. And I want to show you some of these just for historical purposes. Of course, there's the famous Sensorama, which was developed by Morton Hellig, who was a cinematographer. And I think he was in New York, as I recall. And he created this Sensorama machine, which is just crazy to look at. It looks like a 1980s arcade console. But you would simulate riding on a motorcycle through the streets of Brooklyn. And look at the top of that thing. Stereo sound, vibrations, aromas, wind, 3D movies. So this was stereoscopic 3D movies. They're haptics, multisensory experience in the mid-1950s. That's his patent on the right. And I just want to point out that this is his gravestone. He is considered the father of virtual reality. There it is. So filmmaker, inventor, and the father of virtual reality. Now, I've heard of a lot of fathers. I haven't heard enough mothers of virtual reality. It's another discussion. But I've heard of several fathers. I've heard of some grandfathers of virtual reality. But he's the original one. And there it is in perpetuity. So that was in the mid-1950s and the early 1960s. And then famously, there was the Sword of Damocles, which is a rather a strong way of describing it. It was actually kind of a nickname that Ivan Sutherland gave for the first head-mounted display. It hung from the ceiling from this cross, and so they called it the Sword of Damocles, but it really was just a head-mounted display, stereoscopic images. And again, an amazing advance that now looks archaic. And again, we'll look back at conferences like this, and people will say, oh, way back then there was this thing, the Apple Vision Pro, and it was this giant bulky thing that went on your face, and it only had 23 million pixels, and that's what it'll sound like. So all of that occurred, but then that started this incredible explosion in technological advancements and scaling that continues until today. And I really want to point out in the mid to late 80s, the first commercial head-mounted devices and displays, particularly Jaron Lanier. I know that Walter is here and worked quite a bit with him at the time. And I want to show you a video of him describing something in the early 1990s. And it's so remarkable to listen to him. It's only about 30 seconds. But listen closely, because you're going to hear something that's quite interesting. The sound's not great, but you should be able to hear it here in the room.
Well, this is our virtual reality glove. It's called the Data Glove. And the idea is that you can put on this glove, and the glove lets you feel a world that doesn't exist as if it's real and pick up things in the world as if they're real. So it lets you reach into an imaginary world. And these are the special glasses called the iPhones that you put on. And when you put them on, you're seeing inside an imaginary world instead of inside the physical world. So the idea is that by wearing computerized clothing right over your sense organs, you transport your sensory system into a reality that can be of any description.
That's right. He did say the iPhones. EYE. Phones, early 1990s. Put computerized clothing over your sense organs to create new virtual worlds. I mean, it's an incredible insight. And, he was also father of VR, so I'm not sure who the father. He might have been the stepfather. I don't know who's the father anymore of VR, but he's also been called the father of VR. He's written many excellent books. One of them I definitely recommend if you haven't read is The Dawn of the New Everything. I think this review at the top really says it well, a deeply human, highly personal, and beautifully told story about his experiences, both personally, living in the desolate sort of center of New Mexico, and then finding his way out of there and recognizing that he had these abilities that really no one else recognized except him. And then eventually he was able to find his way into the center of what is now Silicon Valley and to create really the major advances in virtual reality. In this book, he talks about how in his lab he would keep a rose. And he would have people in virtual reality. It's fairly pixelated at that time, but they would be just amazed by what they were seeing. And then as soon as they'd come out and he would take the headset off, he would put a rose in their face. I don't know how closely he put it in their face exactly, but he would hold up a rose and have them regard it. And he said people would look at this rose with a new sense of beauty, like just how granular it is and just how gorgeous it is. And they felt like they were seeing the world with enhanced richness after having been in VR. Now, I don't know in the world of Vision Pro if that works quite the same way, but it really taught me something just from reading that when VR is done right, it's not something that we're supposed to be living in. It can allow us to live a fuller, more enriching, real reality, which I always like to call RR. Right? We don't want people to live in dystopian worlds in virtual reality forever, and we're going to hear more about that from Martin Lindstrom next. We want people to learn something about themselves, about their mind, about their body, about their place in the world, that they can then bring with them into real reality to live a fuller, richer life. And that'll be a theme that we're going to come back to. Now, as this technology evolution continued to expand, we saw a series of different headsets, head-mounted HMDs, and these are some of them. And now, of course, we have this. And there's some here to look at in the hall. So this now created the basis for advances in what we now consider to be medical extended reality. And this was the opportunity to start doing therapeutic interventions using these technologies. And so I really need to credit particularly people within the psychology domain, including these individuals, many of whom are here. Skip Rizzo, who is here with us, Tom Furness, Hunter Hoffman will be speaking, Diana Gramala, Walter Greenleaf, Brenda Wiederhold, and many, many others who are not shown here. A group of people who saw this technology and said, oh my God, I think it's so powerful how it affects the human mind. What if we use it for good? What if we use it to try and improve people's lives? And so this led to some extraordinary breakthroughs. One of the most famous, of course, is Hunter Hoffman. Is Hunter here? I can't see right now. I know he's coming. Hunter Hoffman's Snow World. Many of you are familiar with this, but if you're not, it's really important historically to be familiar with this. And look at this. Look at the graphics. I mean, they're really low resolution. But it didn't matter, because people who were in the most severe moments, most vulnerable moments of their lives found that to be a source of relief for searing severe pain. After having a terrible burn injury and undergoing a bandage change, they were able to distract their mind from this experience. And that demonstrated how powerful the mind can be if we can rein in the spotlight of attention. Where do we decide to focus our attention from moment to moment? Because right now, there's no way, if I were to ask you, you would tell me how many times did you blink in the last minute. And you're probably not thinking about the pressure of the chair on your bottom right now. It's just not possible for you to, maybe you now are, but you can't be thinking about all that while thinking about Snow World, because there's only so much our mind can attend to. And that's a powerful insight, because that means we can also swing that spotlight of attention away from noxious stimuli like severe pain, or psychic stimuli like ruminations or phobias. What if we can find a way to move that spotlight of attention and have control over it? And that's one of the main insights of this early research. And this is a study that he showed in a randomized controlled trial, where he had people going through dressing changes that not only could it reduce the worst pain, the sensory experience of pain, but also could reduce the time spent thinking about the pain and the unpleasantness of the pain. So these are cognitive and affective components of pain. We know that pain is not just a physical experience, it's a biopsychosocial experience. That's why opioids might be able to help the physical component, but do very little or worse for the other two components. So that's partly why we're in an opioid epidemic, is we need other ways to solve the pain problem, and we haven't really found those, but they do exist, and that's part of another reason why we need to be in this room promulgating this work. Curiously, they also measured this outcome they called fun, which I've never seen in a study before. You wouldn't think of having fun when you're in the middle of having your bandages changed from a severe burn injury, but fun was had. Now, he also did really groundbreaking work using functional MRIs. Look at the date of this. This is 2007. This wasn't from last year. This was a study where he took people and used a magnet-friendly HMD for the MRI scanner and put a hot thermal probe on the foot. The method sections are very interesting. It's non-injurious, and they had to get IRB approval to put people through pain. And you can see where the pain is. The pain is in the sensory cortex up in the surface, but also in the middle of the brain. You see those flames kind of lighting up. That's the limbic system, the insular cortex, the place where also memories are formed. We remember pain up to a point. We remember painful experiences because they burn themselves almost literally into our hippocampus. But on the right, you can see when VR is turned on, it tamps down all of those signals. Very powerful example of how we can switch the spotlight of attention, in this case instantly, through the use of virtual reality. Now, of course, there's acute pain and then there's chronic pain. And there's been so many advances in the use of VR for chronic pain. This is one of the most famous examples. This is an FDA-cleared device. That is an 8-week treatment program that we have been studying as well through our NIH research. This is a study by Garcia and colleagues along with Beth Darnell at Stanford, where, importantly, they used a sham control. And later today, we're going to hear from Susan Persky, from the NIH, who's going to talk about what is the methodology, by the way, for sham or for control? So we'll talk more about that. And in this study, they found over 56 days there was a separation between the arms using this skills-based virtual reality. Again, demonstrating that not just for the acute pain, but over time we can change the brain itself. And really that's the big insight for me, is to think about the brain as a shape-shifting organ. It's not a block of Play-Doh that rattles around in our skull. It is a shape-shifting, changeable organ like any other organ in our body. And when we learn things, we change our brain. And virtual reality is able to do that. And what I often say, and I've said this before in this conference, is what these research teaches me is even when we are in physical distress, in some of our most vulnerable physical moments, we can still modify how our brain perceives our body. We can't always just fix the problem physically. We can't always just cut out the problem. Even when we cut out the problem, sometimes the problem persists. I'm a gastroenterologist. We'll have people who come with like stomach pain, and then they'll get an organ removed, and then they come back and they say, but I still have stomach pain. And then the surgeon says, but we removed your organ. But I still have pain, and that's because you didn't remove the brain. The brain is still there, and it has a memory of the physical phenomena that burned itself into that brain. So it's not good enough just to do a procedure or fix a problem. We have to work on the brain as well. The brain and the body are all connected. It's one continuous system. Unlike what René Descartes said in the late 1640s when he said, oh, actually the mind is this immaterial thing and the body is the physical thing that ports the mind around. That may be true in some spiritual religious sense, but in terms of modern neuroscience, it's one physical system that works together. So we have to think about all parts of this physical system. This is Skip Rizzo's work. This came along, incredible work using BraveMind for managing post-traumatic stress disorder among soldiers. And once again, he was able to demonstrate how some of the most terrible memories a human can endure can be addressed and confronted using virtual reality. And he was able, in a series of many papers, including randomized controlled trials, and he'll be talking to us later today about how he did this, because there's very few people in the world who have as much experience actually testing in a rigorous manner, in a randomized control manner, these kinds of interventions. So I asked him today to talk about what were the lessons learned after all of these years doing this that the rest of us can take away from this conference. So I'm really looking forward to his talk later. So what he taught me is that VR can serve as a conduit for healing. It allows us to confront and reprocess our most traumatic and difficult memories. And this is only going to continue in human civilization. We are always in a mental health crisis. We all, by the way, live virtual lives. We all live in virtual reality every moment of our lives. You hear music in your head. You hear your own voice in your head. You can see pictures of terrible things that have occurred to you or to others. I can't see that. I can't see any of that. It's in your mind. You are living in a virtual world. It's part of the human condition. So it only makes sense that we use virtual reality to help get into your own mind and modify its contents and its cognitions in a way that is useful to you. And that's what I learned from work from Skip Rizzo. All right, so the next era that I want to talk about that I sort of see in this history of medical extended reality is the era of the empathy machine. To think of virtual reality as a source of empathy for others, and very interesting and importantly, empathy for self. And so I want to talk about some of the incredible work, particularly with the advent of virtual embodiment, and how that advanced our ability to think about different therapeutic opportunities. And for those of you in the room that are still relatively new to this field, these are the core fundamental principles that are important to know about as you start to think in your own unique way about ways to take this technology to improve human health. And these are some of the people that made that possible. Mel Slater, who has spoken in this conference before, Mavi Sanchez-Vives, Courtney Cogburn, Jeremy Bailenson at Stanford, have done some of the most innovative work in this space. And I just want to talk about a few of these studies and what, again, I learned from them as I've gone through my own journey through this process. And a lot of this comes down to work at the University of Barcelona with Sanchez-Vives and Slater. And I was very fortunate several years ago to visit their lab. Back in, it was like 2017 or 16 now, I don't know anymore. And when I went there, I've never really seen anything like this lab. This is one of the rooms in their lab at the University of Barcelona, and it's a rather nondescript room, right? There's 4 walls, there's a humming fluorescent light up on the ceiling, there are these black tarps, there's a chair and some equipment and a table. And they asked me to simply sit down on that chair and kick my feet out on the table. And this was, at the time, Slater's postdoc, Ramon Olivas, who is setting me up. And he's putting haptic engines on my wrists and on my ankles. And then he puts a headset on me, and all of a sudden, that black room turns into this living space. And let's see, is it going to move? There we go, okay. And you can see it's all of a sudden this kind of comfortable space. There's a kind of oversized chandelier, I think, but chandelier nonetheless. And moving around looking at this, this space. And then what happened next is they asked me to move my legs, and they drew these blue lines on the table and asked me to trace out those blue lines. As I'm looking at this, I'm thinking, whose legs are those? I mean, they look like my legs, and they move like my legs in perfect one-to-one synchrony, but whose legs are those? And I thought, oh my God, I think those are my legs. And so I realized that I was now incorporated into this body. Like I had embodied this digital manifestation of myself. Now he doubled down and he started taking balls from the ceiling, and each time the ball hit my body, I can feel the vibration motor in my suit. And I physically felt the phenomena of these balls hitting me. And that reminded me that I actually was a physical self. I was actually in this body. He called this full body ownership. And now what happened next is hard to put into words. And I still remember it as if it was yesterday. This was years ago now. And it's really indelible. It's hard to even explain until you go through something like this. He then separated me from my body. And I started to float up into the ceiling. And those balls continued to strike me, reminding me that I was still a self, but I wasn't that self. I had been removed from this body that I had just occupied before, but I noticed that it was vacant and it was still. It wasn't moving. And I had this moment that I still remember today where I thought, I think I just died, right? Did the lights just come on? Oh, somebody's hit the light. I feel like I just passed away. And it was like almost a spiritual experience to have died in virtual reality. And the amazing thing about it is, even to this day, I feel like I now think of death itself, the actual process of death, as non-catastrophic. It doesn't have to be a catastrophic experience to pass away. And I actually learned that from this experience because it felt, in a way, very uplifting in this strange way. And the amazing thing is he has studied this and demonstrated that a virtual out-of-body experience does reduce fear of death. He's demonstrated this in a controlled trial. It's actually a randomized controlled trial, and the methods are quite remarkable. And so this is just powerful stuff. It demonstrates that VR is a tool for perspective taking, for perspectives on your own mind and body, and as we'll see, perspectives on other minds and bodies. If we use it to recalibrate unhealthy perceptions, VR becomes a radical new tool or new therapy to improve quality of life. This is another example I now want to show you from the same laboratory. This is the work from Mavi Sanchez-Vives, where she put me in a headset, and I looked down and I noticed that I'm in a different body. I am a woman. I feel and look like I'm in a completely different body. And I now find myself in an apartment, and this guy walks in, and this is what happens.
Have you seen yourself in the mirror?
You turn the sound up a little bit.
Where do you think you're going looking like that, huh? You shut up. You could put some effort in and dress up or something. Look at me. Jeez, you look 20 years older than you actually are. Do you know, there's not one woman out there who looks as wretched as you do right now. I said, shut up, you fat cow. You're disgusting. Aren't you going to say anything? I said, look at me. Yeah, of course. Nothing. Typical you. This is all my fault. I've been too soft on you. Yeah. I've been too patient. But you know why? Because I love hug you.
All right, so that's disturbing. I mean, it's really disturbing to watch that, but to be in it, to be in an environment that literally feels that you're there, and as tall as the user is, this guy's always taller, he's always looking down on you. It's really disturbing. Like, I still remember that moment, coming out of that and being really disturbed by that, right? And to be honest, like, ever since that, I think of domestic violence a little differently. Not that I, of course, didn't appreciate the importance of domestic violence as a diagnosis and as something that needs to be managed and addressed and the roots of it. But now when I see, an alphanumeric code in my electronic health record, a completely, emotionless code for domestic violence, I go back to that moment in Barcelona. And I think about, what must that be like? Right? I can't pretend to know what it's like to be the victim of domestic violence, but I at least can say that I've simulated it, and that's the first steps for empathy. And that's what the empathy machine is all about. That is a profound experience for me. And what's even more incredible is she's demonstrated that when offenders of domestic violence in the justice system, in the Catalonian justice system, are exposed to this very program, they get a little taste of their own medicine. It's unfortunately a little Clockwork Orange-like, to be honest. But they're able to experience what it's like. And she's been able to show that she can literally change their cognitions about domestic violence in really powerful ways. You have to read the paper to learn more about. So that is powerful stuff. And Chris Milk famously said that VR connects humans to other humans in a profound way that I've never seen before in any other form of media. It can change people's perceptions of each other. And that's how I think virtual reality has the potential to actually change the world. So this is the era of the empathy machine. We're still in it. There's incredible opportunities, and we'll talk about some more. Here are some others. VR has been used to experience life in somebody else's body, somebody of a different background, different demographics, to generate empathy for Syrian refugees, for homelessness in Los Angeles. The effects of VR empathy are so extensible that Jeremy Bailenson, years ago, even put research participants into the body of a cow and felt what it's like to be shipped off to the slaughterhouse, right? And so look at the old animation, but it's really powerful stuff. This is a picture of somebody coming out of one of these experiences, and you can just see how he's trying to unpack what just happened. So this VR is not just about gaming and entertainment, right? It's not just about, pimply teenagers playing first-person shooter games in their parents' basements. It's about this too, and that's the power of VR. Now, this is another example in medical education of empathy. This is from the UK, and I want you to watch this video because this is a medical student who is practicing a very difficult conversation with a patient. And you can see in the title, they called it the unreasonable patient. I'm not sure that's the best term, but everyone has their reasons, but okay. But that said, you can see that this is rather lo-fi, but just watch how involved. You can see like he's really getting into the situation, and he's learning how to be empathic. In a world of artificial intelligence, where AI absolutely very soon will be making diagnoses, I promise, it already is. I use AI in my clinic now. I think before long, I've heard Daniel Kraft say this, it may become malpractice to not use artificial intelligence to make diagnoses. Okay, we'll come back to that in a few years. But in a world where we have computer systems that are going to make diagnoses, that can prescribe a course of therapy, that can send all of those orders through the electronic health record, what is the role of the doctor or the clinician? Well, shared decision-making, empathy, looking people in the eyes, right? Having human conversations, the wisdom of the human, doing physical exams. Like, we are more important than ever in this environment. And so it's systems like this that can help us train our doctors to be those kinds of people.
Unfair. It's going to ruin our holiday. I'm going to take this up with the local health authority. I think you are unfairly denying medicine to my mother.
Okay, I appreciate your concern. Thank you for your feedback. I do think that the best medical practice at the moment is to manage this conservatively for now.
My mother worked and paid national health insurance all her life. Now look at what's happening.
Sure. I mean, this has got in no way to do with your mother's health insurance payouts. I believe this is the best medical practice at the moment for your mum. I think the use of antibiotics in terms of the risk and the side effects that they can produce, such as resistance to future chest infections or problems with the stomach, mean that it's probably better to not prescribe them and to seek medical attention in France should things get worse, which I'm not
They say
expecting.
on the news that old people are just invisible.
She just keeps going.
Not treated with respect by the NHS.
And you can see he's nodding. He's done this before.
I appreciate your concerns.
This is another example. I see Dr. Bernice Coleman is here with us today. She initiated this program with the Holman United Methodist Church and Pastor Calvin Sauls. This was a study, again, the idea is empathizing with others, but also empathizing with self. This was a study where we worked directly with the parishioners in a church to develop a culturally tailored program to help manage blood pressure. And the idea was to identify where does salt live in the diet and how can we lower salt intake and therefore reduce blood pressure, a biological endpoint, systolic blood pressure. And so the way this worked is the participants would go into a kitchen in virtual reality and see different meals and then find out how much salt is in that meal. And then they would go flying through their body. It was very dramatic, lots of music. It was almost kind of scary. And watch as the salt just erodes, the blood vessels and the heart and the kidneys and the brain and the blood pressure is causing. And then you come back into the kitchen and there's a beach out there. And you go out to the beach and then you pray on it with your pastor. And the question is, do you want to make a difference in your life? Are you prepared now to change your diet and to change your life? And the amazing thing is that it worked. Dr. Coleman and her team found a 7-point drop in systolic blood pressure just from using this program. And at this inaugural conference in 2018, Pastor Sauls came up on the stage and he said something that I still find so powerful. He said, I love technology, don't get me wrong, I'm all about high tech, but that has to be accompanied by the personal touch, by the holy touch. It's not just about putting a screen in front of people, it's about inviting people into catalytic spaces so they can participate in meaningful engagement. And that's a really important concept. Digital health is not just a computer science. It's not just an engineering science. It's a social science. It's a behavioral science. That's why there's so many behavioral psychologists in this room. Omer Liron is the psychiatrist. He's here, and this is another example of empathy for self. Here, he used virtual reality to treat HIV. I mean, who would imagine using virtual reality to treat AIDS? What is the mechanism of action here? Well, he found that some people were simply not taking their medications because they didn't really understand exactly what it was doing in the body. So he created a VR program with his own voice as their doctor.
Floating by? That is a virus, and it's called HIV. You may be wondering how something so small can be so deadly. Just watch.
So just imagine you're in that blood vessel. You hear this music start.
The HIV was able to enter the immune cell and is now copying itself over and over again. The immune cell can only take so much until it bursts. The HIV copies can now infect other immune cells.
But here comes the medication, which the patient can activate through the hand controller to put a
see
force
that thing
field
floating by?
around that immune
That
cell
is a
to block the HIV from entering. When he did this study in a controlled manner, not only did people stay more adherent with their medications, but it reduced their viral load. Like, it actually reduced their viral load of the virus in their body through a one-time intervention with virtual reality, taking advantage of the presence. You can't do this easily with a brochure on a piece of paper or watching a screen or hearing somebody lecture to you. That's the power of VR. So as we end this talk and move on to the rest of our two-day session, I want to talk about this latest era, which I'm going to call the rise of MXR. the rise of medical extended reality as a codified field, as an actual field of medicine now, a field that has organization and has standards and structure. What has happened in the last few years is just that. This was from March of 2020 when the FDA, and we have folks from the FDA today, first introduced this term medical extended reality, or MXR. We were fortunate to be there. Very interesting to be somewhere where, let's see, my laser's not working. We have Cedars-Sinai and Johns Hopkins and Stanford together with Microsoft and HTC and Facebook. That's an unusual branch of medicine to bring those folks together. But we now have, there's the website on the left. This is a branch of medicine, a regulated branch of medicine. We developed recommendations for how to develop and validate VR therapeutics. And I'm going to go through these later today briefly in our session on research for NMXR. Just like the FDA has phase 1, phase 2, and phase 3 trials, we described at the time VR1, VR2, and VR3. Maybe it should be XR now. We started to get reimbursement from insurance carriers and from Medicare for FDA-cleared therapeutics. We now have a medical society. Is Mark here? I haven't seen Mark yet. Where's Mark? He's here somewhere. Mark Zhang created the American Medical Extended Reality Association. If you're not a member, please join. I think it's $100, and it's a way for all of us to band together, along with Bob Fine and the International Virtual Reality Healthcare Association. And the two of these associations have now come together to support our new journal, the Journal of Medical Extended Reality. So in all of your bags, you have a handout from the Journal of Medical Extended Reality, and we're so proud to have an incredible editorial board from some of the top thinkers from around the world, many of whom are in this room. I can see Korak's here, and Brenda's here, and Susan's here, and go through every one of these names. Rohan's over here, I see Keith's over there. Every one of these people is a major thinker in the space, interdisciplinary, international, and have all come together from the VA, from the FDA, from the NIH, and from multinational universities to bring together this new journal. So we hope that you all will be interested. There's Melissa. Melissa's over here in submitting to this new journal. We had our first papers published in January and already have had 2,000 downloads in the first 2 weeks and now over 3,400 downloads year to date from the papers that we just published a few weeks ago. As I said, we've partnered with IVRHA, and we are now developing new guidelines. If you are interested in a guideline topic, you can come to me, let me know. We're going to start writing guidelines through the AMXRA, IVRHA, and we're talking to the VA as well about a joint unified guideline. These will be published in JMedXR. This was the first guideline published in the journal. What is medical extended reality? A taxonomy defining the current breadth and depth of an evolving field. And this is a picture of what this field now looks like. So this field has 5 pillars, and you can read the paper. It's in your handout or it's in your bag to learn more about how we even conceptualize this new field. So as we kind of wrap up this talk, it's time to think differently about this field. These are pictures that I showed last year at this conference I'm going to show again. These are pictures that most people think of when they think of virtual reality. We need to start thinking less about pictures like this and more about pictures like this. Pictures like this, not very helpful. Pictures like this, much more helpful. And I showed this last year, and I want to show it again. And in the last year, I've lost my mother-in-law to advanced dementia. And here's a patient with advanced dementia who moments before this video was taken was overwhelmingly confused, was crying out in pain. But then they put her on a beach from her childhood, and then this started to happen.
Gonna see, I'm gonna see, I'm gonna see, I'm gonna see.
Beautiful.
Oh, look at it. You wouldn't believe this was there, would you?
No.
If you didn't come here to see it, you would never know that it's even blue.
It is blue.
Oh, it is blue.
So this is why we're here. It's experience narratives like this. It's stories like this. This is what medical extended reality is about. It's about finding moments of awe and wonderment when people are at their most vulnerable, in the most pain, physically, emotionally, socially. It's about finding moments of escape when people need it the most. And it's about finding new ways to integrate these technologies in the care of health, in the delivery of healthcare. So each year I end with grand challenges for the next year. And this is what my hope is for us to think about during this conference. To think about, how do we unify this field? How do we find ways to continue to grow this field so this room gets bigger and bigger each year? How do we figure out how to advance the science to learn from the people that taught us all this? People like Skip Rizzo and others around this room. How do we make this field more accessible? How do we make it more affordable? And how do we do all of this and improve the lives of the patients that we serve? So I've written a lot about this in this book that I published a few years ago. Take a look at that if you're interested. And again, I want to thank you all for being here. I always get choked up at the end of these things. Thank you. So I want to invite up all the people that made this event happen, because there's lots of people to thank to make this kind of event occur. So I want you all to give a round of applause to these people. So these guys work year-round, and thank you. That's all I can say. I always get choked up. Muskan especially done a lot of work to make. So those of you who have been on the email, yeah. So thank you all. All right. I've gotten a hold of my emotions now. I may need VR to calm myself down. Thank you all again. So they're going to be around. They also have these helpful pins if you have questions over the course of the next 2 days. So look for anyone with a pin. And thank you all for your help. All right.